Dear viewers, in this video I have come up with another topic which is frequently asked in competitions, that is solubility of an ionic solid in water. Now the solubility of an ionic solid or crystalline ionic solid in water depends on two factors, that is lattice energy, which is denoted by delta lattice H, and hydration energy, which is denoted by delta hydration H. Now let's discuss first this one by one. Lattice energy is the enthalpy change involved in the formation of 1 mole of an ionic crystal formed from its constituent gases, positive and negative ions. For this, let's see, suppose NaCl is the ionic crystal we are dealing with, and it is formed of the constituent ions Na positive and Cl negative. So 1 mole of Na positive ion and 1 mole of chloride ions when together combine to form 1 mole of NaCl ionic crystal, then the energy released in this process will be equal to the lattice energy, that is energy released in the formation of 1 mole of an ionic crystal from its constituent ions is termed as enthalpy change or lattice energy. It is also, you can say, the enthalpy change involved in the above process is negative. Its value will be negative because a definite amount of energy is evolved during formation of 1 mole of an ionic crystal. That is, the energy is evolved in the process, and therefore the charge on the enthalpy change will be negative. Lattice energy or enthalpy change involved in the above process decreases with the increase in ionic size. If the smaller will be the size of the ions, greater will be the lattice energy, and if larger will be the size of ions, smaller will be the lattice energy. Now let's look at the another factor, that is hydration energy. Hydration energy is denoted by the term del hydration H. Now it is also, you can define it by saying that enthalpy change involved in the hydration of 1 mole of gaseous ions of each type of an ionic solvent. That is, when you dissolve an ionic crystal in water, then the hydration of 1 mole of each of the ions involved causes release in the energy or releases energy in the process, that is termed as the hydration energy, and it is also negative. Enthalpy change involved in the above process also negative because a definite amount of heat is evolved during hydration of 1 mole of gaseous ions. And similar is the case here also, as I have told you that lattice energy decreases with the increase in size of ions. Similarly, the hydration energy also decreases with the increase in the size of the ions. So smaller will be the size of the ions, greater will be the hydration energy. Now the enthalpy change of the solution of an ionic solid is numerically equal to the difference between the hydration energy and the lattice energy. The difference between hydration energy and lattice energy gives the enthalpy of the solution of an ionic solid, that is solubility of an ionic solid in water. So for a compound to dissolve in water, the equation will be del G should be negative, that is free energy change should involve will be negative because it is a spontaneous process. So the equation is del G solution is equal to del solution H minus T del S, that is again the solution, that is enthalpy, entropy and free energy change. This should be negative. So since this del S is positive, entropy change is positive, and if del H solution is also positive, it should be numerically lesser in value than T del S, because unless and until this quantity will be smaller than T del S, del G value will not be negative, and greater will be the negative value of del H solution. It will help in the greater dissolution of the salt, ionic salt in the water. Now if as del H lattice, that is lattice energy, is negative, as we have seen in the earlier case, del H is negative and it should be negative for a stable crystal. In an ionic crystal, the lattice energy is always released in the process, it is always negative. So from this we can conclude using equation 1 that if hydration energy is greater than lattice energy, then the enthalpy change involved in the hydration of the 1 mole of gaseous ions of each type involved in the ionic solid is greater than the lattice energy evolved in the formation of 1 mole of an ionic crystal, then the salt will dissolve in water. But if hydration energy is less than lattice energy, then salt ordinarily would not dissolve in water, but it can only dissolve when del H, this del H is lesser in quantity or lesser in numerical value than T del S. Then only it can dissolve. Otherwise, this process or this condition will lead to the will not lead to the dissolution of salt in the water. So solubility of an ionic solid in water depends on two factors, that is lattice energy, that is the energy involved in the formation of 1 mole of an ionic crystal from its constituent ions, and hydration energy, that is the enthalpy change or the heat evolved in the hydration of 1 mole of gaseous ions for each type, and both should be negative or both are negative involved in the process, and both the factors decreases with the increase in ionic size. So if size decreases, the hydration energy will increase, and this is this equation which represents the relation between both of them. The solubility will depend on the difference, numerical difference between the hydration energy and the lattice energy. And if the hydration energy del H is obviously negative, so in that case, if hydration energy is more than lattice energy, then salt will dissolve in water, and if hydration energy is less than lattice energy, then the salt will not dissolve in water, but it can only dissolve when del H value is less than T del S value in this case, because then del G will become negative and then the compound can dissolve in water. One more thing I want to continue in this video. If any of the students of class 9th and 10th or any other class 11th and 12th, you want me to give you the written notes, handwritten notes of any chapter, you find it difficult, then you can contact me on the WhatsApp number I am giving you at the end of this video, and you can message me there, and the notes will be paid, so I will interact with you or you can message me personally on that number, and then I can accordingly tell you how to proceed with that.